Assalamu alaikum. So we have an original signal which is analogous, and the equation of this analog signal looks like this. Here capital F is called analog frequency, which is the frequency of this analog signal. Then we have obtained a sample signal, and the sampling rate is Fs, which is also called the sample frequency. And we have sampled this signal which is not continuous, and the equation looks like this. This equation can be written in the another form which we will use here in this video, which is 2 pi small f n plus theta. So what is small f? Small f is simply equal to f divided by fs, and this small f is also called digital frequency. Okay, so let's dive into our video. In this video we will see the periodicity of this sample signal. That means this sample signal looks like periodic. This sample signal looks also like periodic, but this sample signal is not periodic. Though the original signal is periodic, the sample signal is not periodic. Let's see why this is not periodic. If you choose this point whose voltage is, let's say, 0, this 0 volt is not coming here periodically. One 0 volt accidentally comes, but this 0 volt is not coming periodically. If you see this voltage level, this is also not coming periodically. Let's compare with the previous periodic signal. If you see that this 0 volt again comes, that means this 0 volt is coming periodically, but this 0 volt is not coming period. That means this signal is not periodic. And if you observe carefully, here fs is pi into 10 to the power 3, and here fs is 5 kilohertz. That means the different fs makes the sample signal one periodic and another not periodic. So let's see why this thing happens. So this is our sample signal, a discrete signal. Let's say in a specific time we have a n, and in this n we have a voltage level which is equal to xs in the bracket n, and after some time let's say we have a different n which is n plus capital N, and here you have a voltage level looks like this. And this signal, this 2 voltage level may be periodic or may not be periodic, but if this 2 signal is periodic, then we can write that these 2 voltage signals are equal. So in this video we will find a condition for small f, which is digital frequency, that is equal to f divided by fs. So we have to find a condition for which a signal can be said periodic or it is not periodic. So let's start. So let's say we have a cosine signal. It's an sample signal. So a cos 2 pi small f, then n plus theta, where n is equal to 0, 1, 2, 3. That means integer number. This is the signal here, and after some time, let's say we have a different signal when n is n plus capital N, and now we have to write here like this. Instead of n, now we have to write n plus capital N. Okay, now let's write 2 pi small f into capital N here, and then 2 pi f small n plus theta. Okay, so we have 2 different voltage levels at different time. So now this signal may be periodic or not periodic, but if this signal is periodic, we have to say that this voltage level and this voltage level is equal to same. That means xs n and xs n plus n is equal. Now let's see one thing. This is a cosine signal, right? So let's say cos c. Okay, let's say cos c. C is some angle. Cos c is equal to what? Cos 2 pi plus c, right? Cos 2 pi plus c can be written as cos c. Again, cos 2 pi into 2 plus c, this is also equal to cos c, and cos 2 pi into 3 plus c, it's also equal to cos c, right? That means here we have 1, then 2, then 3. That means if you have integer number after 2 pi, that means that cos c will be equal to cos that. That means cos c is equal to cos 2 pi. You have to write an integer number here, that is, let's say k plus c, where k is an integer number. It can be 0 or 1 or 2 or 3 dot dot dot. Okay, so if you understand this thing, let's see what happens here. So this is, you assume that this is equal to c, so this is also equal to c. So when this signal, this voltage level and this voltage level will be same, if this thing is equal to 2 pi k, right? If you have a 2 pi k in front of c, if you have 2 pi k, so this 2 cos will be same. That means 2 pi fn is equal to 2 pi k. 2 pi cancels out, so small f is equal to n divided by k. Okay, now let's analyze this thing. F is equal to n divided by k. So f is digital frequency, which is equal to n divided by k, and n is equal to 0, 1, 2, 3. K is also equal to 0, 1, 2, 3. And if this is so, then we can say that the signal is periodic. That means our signal will be periodic if this is true, and from here we have obtained this n divided by k. So if f is equal to n divided by k, then our signal is periodic. Let's give you an example. Let's say f is equal to 2 divided by 5. That means n is equal to 2, k is equal to 5. So it's a rational number, right? So it's a rational number, so it's periodic. If you have 10 divided by 5, so n is 10, an integer number, k is also an integer number. That means the total is a rational number, so this 2 signal is periodic. But if f is equal to 3 divided by pi, let's say 3 divided by pi, this signal is not periodic. Why? Because our condition is n should be integer, k should be integer. Here f is equal to k divided by n, right? So f is equal to k divided by n, k divided by n, k divided by n, k divided by n. Okay, so if here k is an integer number but n is not integer number, so it's not periodic. And you can also see that this small f is an irrational number. That means if small f is a rational number, the signal is periodic. If small f is irrational number, the signal is not periodic. Now let's see this thing in our previous 2 signals. Here you have small f is equal to f divided by fs, which is equal to 1k divided by 5k, and it's an rational number, right? and as small f is rational number, the signal is periodic. But here, if you have f is equal to f divided by fs, capital F analog frequency is 1k, and fs is equal to pi into 10 to the power 3, that means 1 divided by pi, and you can see that the small f is an irrational number, and that's why as small f is irrational number, so the signal is not periodic. So the moral of the story of this video is, if small f is a rational number, the sample signal is periodic. If small f is an irrational number, our sample signal is not periodic, though our original signal is periodic. Thank you.